Hi, this is Prasad, and this presentation is about locating popular places with spatial data mining techniques. To understand the spatial data analysis like aggregation and clustering techniques for finding popular places in San Francisco, Bay Area, California, and for setting up new startup. And the data, spatial data obtained from Govala social network media which is in work from 2007 to 2012. From this case study, we can analyze Govala users check-in data, like each data point represents locations they visited. Using this check-ins data, how can we identify popular areas? As we can see, this point data is like very clustered. The information from the map is densely clustered, and how much knowledge we can gather by glancing at the map alone. So for this, two statistical methods were followed, like aggregate check-ins and quantify its significance with spatial autocorrelation, and next detects spatial clusters using DB scan, HDB scan, and optics. So these aggregate check-ins, as we can understand the complexity of the check-ins spatial data, like it seems that the point data is covered the whole San Francisco area. So we partition each spatial data with a grid of hexagon bins that covers the San Francisco Bay Area and use these grids to aggregate check-ins. And we can observe that the pink hexagons bins have a higher number of check-ins while the blue have lower numbers. We'll observe in the notebook how this data was generated. We need to adjust the coordinate systems for both the data obtained and the topography base map. Uh, First, the hexagon layer. This hexagon layer was obtained by uh, for, by generating tessellation method. Which we can observe this the spatial data and the tessellation hexagons can overlap, and these hexagons which are overlapping the spatial data can be obtained later and count the number of hexagons by using this select by layer method. After performing this method, we can observe the hexagons are highlighted, and using the spatial join method we will separate the only hexagons which are overlapping the data points. And the patterns observed above are like they are whether they are statistically significant. We need to test using this Moron's index, and also we can check whether the sample data are random variance having random variance or sampling errors. So we have used this global Moran's statistic to test its significance, like the results are whether they are clustered, dispersed, or random. Here in this report obtained from this spatial autocorrelation, the clustered icon was highlighted, showing the red with the z-score of 6.4. The z-score is a significant value being measured to check the amount of spatial autocorrelation that exists between features in the data. And the chart highlighted the clustered, which means similar values in the data are closer together. And we can also observe these reports how we perform using this spatial autocorrelation statistics method with a joint count as an input field, and the conceptualization of spatial relations with the inverse distance. The distance method is Euclidean distance, and standardization as a row. And the methods was using JSON. I just printed out the G score and all. You can also see this report. Next, coming back to the final finding the spatial clusters. From the previous report, we can confidently say that the check-ins are not randomly distributed but clustered. So we will continue finding most popular places by cluster analysis. We use density-based clustering methods like dbScan, HDBScan, optics for finding popular places in Bay Area. We don't know the exact number of check-ins that make a place popular, but we can estimate based on our business circumstances. Let's say at least 500 customer check-ins make our business profit, so we can define the minimum number of features per cluster to be 500, and the search distance to be about zero point 0.1 miles, like average block size of the city. And coming back to the notebook, I've used this density-based clustering stats method, which we can see the input features layer and it's taking as the Bay Area point data as input, and the cluster method as dbScan. The output features method will be given shown as this dbScan output. The minimum feature class is taken as 500 check-ins. Such distance will be zero point 0.1 miles, and we can observe these points as the clusters in this map. And at the same time, we performed a HDB scan. The next method, like using a single fixed data distance, like we used 0.1 mile in the DB scan, but here HDB scan has the facility to use multiple distances, because the fixed data may not yield the best results because our study area includes urban, suburban, and rural locations. Therefore, the self-adjusting HDB scan employed for this task. It is like iterating the DB scan many times with various search distances. At each search distance, it finds several clusters in various places where dbScan tries to combine these clusters to form a bigger cluster with a common point density. Because of this, there is no unique search distance that characterize the generated clusters. So compared to dbScan, the HDBScan method detects more clusters. As we can observe, this is the result of HDBScan. We are having more clusters compared to the dbScan, and observing the data, real data, and the HDB scan method seems to be more realistic. And I also performed the optics method with sensitivity value 0 and a sensitivity value of 100. These optics methods are very time consuming. They take like 20 to 30 minutes for each operation of each method. So I was not including the results of this method in this presentation, and I'm only taking HDB scan results. In this method. So the highlighting areas are because we also have a noise cluster. We want to choose only the highlighted areas without the noise. The blue area which overlaps the colored area are the points which are highlighted, and the probability distribution seems to be the selected probability in the blue color area. And I also perform this optics method. We can see the reachability order, how the reachability distance and the reachability order here. And we can observe these graphs. Finally, the red area seems to be more popular, and I have explained in the notebook, and these are the references. Thank you.